So this is the Lambda console. I hope you already know how to go to a Lambda console. So type Lambda here and then you can open it from this page. If you press on star, it will come in the favorites bar. Okay, and these are the options available. We have dashboard, and the dashboard will tell you how many Lambda functions are there, how much amount of data is getting used for the code, or let's say you have 200 Python codes, how much amount of storage it is using. Then there's something called Lambda concurrency. I'll talk about Lambda concurrency shortly, but before that, let us go ahead and create a function. Now we have certain applications here. We can create a Lambda application. Now this is something we are not interested in because we want to look at Lambda from the prism of data engineering only. We do not want to consider Lambda when it can be used as an application. We do not want to do that. We want to use Lambda as data engineering. So in that case, the most common use case is whenever you upload a file in S3, you want to have some automated processing, or you have sent some data to SQS. Lambda should pick up those data, those messages, and then do some processing. So I'll show you using S3, and the other things would be pretty much similar. Okay, but before that, I have to look or create Lambda function. So what is this Lambda function? Now there are multiple options. We have authored from scratch. We can use a blueprint or we can use a container image. Now let's say you are using some programming language which is not supported by Lambda. So in that case, you can use a Docker container image to deploy the code. Again, this is application level stuff, so let's not bother about it. We'll author it from scratch. And I'll name the function to be 3IAM S3 data processing function. So this is the name of the functions. As you might see that these are basic information that you have to provide. Then you have runtime. So runtime tells you the programming language that you want to use to execute the function. So whatever programming language you use, you have to write the code using that programming language, or you have to upload the code in S3 and then execute it. And these are the options available. There's .NET 8, Java 21, Node.js, Python 3.13, Ruby, Amazon Linux, and some older versions also. So of course, we'll use Python 3.13. Then you have architecture. This is the CPU architecture. There are two types of CPUs which are supported by AWS. So one is the Intel based, which is x86_64. So this is the instruction set. The other one is the ARM CPU, which is the instruction set for Graviton CPUs. So I'll use the Intel one, and then you have permissions. There can be multiple execution roles. We'll have to use an existing role. Now let us go ahead and create that role first. You know what to do. You have to go to IAM, and then I'll create a role here. Now the role would be for an AWS service, not anything else, but for an AWS service. And in the use case, I'll mention Lambda. So here we have Lambda, and there is only one option available, which is Lambda. Click on next, and here I can mention permissions, which you already know by now. So let's provide Amazon S3 full access, because that is the service that I'll use to trigger Lambda function. Okay, so I'll name it as 3IAM Lambda S3 execution role, and that's it. I'll create the role, and once it is done, I'll go ahead and refresh it here. So I should be able to get the 3IAM Lambda execution role here. So I can use this. Now this Lambda function has access to S3 service. Then there are some certain additional configurations like networking. Of course, you have to provide network. You can choose not to provide a VPC. In that case, Lambda would run in a public VPC, or the default VPC which is there in AWS. Of course, you should enable VPC, and I'll be selecting the 3IAM Spark VPC that I have been using so far. And the subnets would be the public subnets only. I'll not use private subnet. So as of now, this is the first subnet, which is public subnet 1A, public subnet 1B, and public subnet 1C. So these are the three AZs that I have selected, and I have done it intentionally because whenever we execute Lambda and whenever there's a requirement to scale up, the new execution instance of the code would be launched in a different availability zone. That's how Lambda provides us high availability out of the box. Then the security group, I will select the 3IAM Spark VPC public security group. That's it. And I do not want to use any security and governance As of now, this is something that you should consult with your AWS security guy before using it. And tag is something you already know. Let us go ahead and create the function. Okay, it says that it does not have permission to create network interface on EC2. So we'll have to provide that also. Let's use the Lambda S3 execution rule. So I'll give AWS EC2 full access. Had I given admin or administrative access, I would not have to bother about these things. Let's try to create it now. Now the Lambda function has been created. Okay. So now here it will show you the function and lot of other things like the code, test, monitor, configuration, alias and versions. So I'll come back to code later on. The first thing that I want to talk about is the configuration. And testing is related to code. Of course, once we write the code, then only you'll be able to do the testing. So I'll come back to code and testing later on. But let's go to configuration. And here, there are a lot of configuration available which were not shown while creating the function. And these are the configurations that you can apply or modify only after the function is created. The function creation is not complete yet. Once it is complete, I will go ahead and show you how we can do the configuration here. Alright, the function creation is done. And now let us do the configuration. So in the general configuration, there are a few things. Here you can mention the amount of memory that you need for this program. So in this case, I'm just saying I need 128 megabytes of memory. You can click on edit here and you can change it. The minimum is 128 MB and the maximum is 10 GB. So I'll change it to 1 GB maybe. So 1024 MB, which is approximately 1 GB, and you'll get corresponding amount of vCPUs. You can go ahead and take a look at the EC2 instance types. What is the number of vCPU that you get for 1 GB of RAM? So you can expect those many number of vCPUs or maybe number of threads. Then you have ephemeral storage. This is the storage that your program can use while executing. So this is something I'll keep it as is because the program that I'm going to write will not use any ephemeral storage. By the way, if you want to use the ephemeral storage, it will be available in this particular directory, which is /tmp. I hope you can see it. So this is the directory where the ephemeral storage would be available. The next one is important. This is timeout. And the maximum timeout that you can give is 15 minutes, not more than that, after which the execution will be terminated. Right now, I have provided 15 minutes, but of course, it should not be that high for our processing. If we want, we can change it later on also. This is the role, which is the execution role. So the first configuration is done. Then you have triggers. No, we did not add any trigger because while creating the function, there is no way of providing the triggers. So here you can click on add trigger and it will tell you what are the ways you can execute the Lambda function. So there are various options. The first one is API, interactive and web. You can use Alexa, you can use API gateway, application load balancer, code commit, VPC, lattice, etc. Then you have batch or bulk data processing. And here you'll see SQS, S3, CloudWatch logs, etc. Then you have real-time data processing also like DocumentDB, Kafka, DynamoDB, Kinesis, MQ. Amazon MQ is a managed service for ActiveMQ and RabbitMQ. Then there is MSK also, which is managed Kafka. Then there are partner services, which is powered by Amazon Event Bridge. So you have Auth0, Authres, Benching, CleverTap, etc., etc., Datadog, etc. So these are the various triggers available. The one that we use for data engineering is S3, SQS, sometimes Kinesis, sometimes MSK. I have not seen it getting used, but yes, you can use it if you want to. As I said, you will not get the APIs of Spark because Lambda does not support Spark Distributed Processing Framework. So let's select S3. The moment we select S3, it will ask you to provide the name of the bucket. And then we have event types. Let's just provide the bucket. And this is the bucket, which is 3IM Data Engineering Volume 2. Let me show you the bucket. So I have 3IM Data Engineering Volume 2. This is the folder 3IM Spark. And here I have created two additional folders. One is Lambda input and the other one is Lambda output. The reason I have done so because what I'll do is I'll upload a file in this folder first. then we'll see that the Lambda would be triggered automatically. Then I'll copy a file to this folder, then also Lambda would be triggered. Then I'll delete a file, and then we'll see that Lambda getting triggered automatically. All right, so how do you do the trigger? Here we have event types. So there are multiple events that are possible. All object create events. These are the events which are used to create an object in S3. For example, uploading a file in a folder or a bucket, copying a file from another bucket, another folder to this folder. That is also create object event. And these are the HTTP requests for those, like put request, post request, copy request, multi-part upload, which I have shown you in S3. Then I have object delete events also. So I'll select object delete as well, and all object create events. There are some options available from like restore from Glacier initiated, restore from Glacier completed, object in RRS lost. These are something which are not used in data engineering, so I'll not talk about these. So I've selected all object create events and all object delete events. So these are the events on which the Lambda code will be triggered. I have not provided the code yet, but based on these events, whenever we upload a file, whenever we copy a file or delete a file, this Lambda function will be triggered, which in turn will start execution of the code that we provide, which we have not done yet. Then you can provide the prefix. Of course, you have to do that because we want to make sure that you provide the correct folder. So it is 3IAM Spark, and inside of that, I think I have created the folders in the input files folder. That's okay. And then I'll use this Lambda input folder. So this is the only folder that I want to use. There's no suffix that I need. And what it says is that we should not use the same bucket for input and output, because in that case, there might be recursion problem or kind of infinite loop. Of course, I'll not do that because I have provided a folder. So I'll acknowledge that and then click on add. So this is the trigger. Now you'll see in this diagram, this is the S3 trigger. I have not added any destination. So this is the second configuration that is needed. Then you have permissions, which is resource-based policy, which is automatically added. And then we have destinations. I'll not add any destination as such. Function URL, this is needed for applications and APIs. Then you have environment variables. Now these are the environment variables for the code that we have not written yet. So I'll keep it as is. Then you have tags, you already know. Then VPC, you have already configured the VPC, so nothing else is needed. Then RDS database, again for application monitoring and operation tools. If you want to add some monitoring tools like OpenTelemetry, Prometheus, etc., you can do that. Again, not needed for data engineering. Then you have concurrency and recursion detection. So what is this concurrency? Okay, so let me tell you how the code would be executed. So let's say you upload one file. So this Lambda function will get triggered and will execute the code that we have written or we have provided to this Lambda function. What if you upload another file at the same time? What would happen? This Lambda function will again get triggered and another instance of the same code would run, of course with a different data. If you upload another file at the same time, then the Lambda function would be triggered again and it will execute a third instance of the same code that we have provided to this function. Now all these codes are executing concurrently. It's the same code which is getting executed, but the execution trigger was for different files and they would be dealing different files. So this is called concurrency, and by default we get 1,000 concurrency limit. This is a soft limit. Of course you can increase it. We can provision the number of concurrency also, in which case we'll have to make some additional upfront payment. But that's what concurrency is. What is the maximum number of code execution instance that can be done? Meaning at the same time, how many parallel instances of the same code would be executed? That's what concurrency is. And the other things are something that are not needed, and this is what the configuration is. And this is how we create Lambda function. So let me just do a recap. We have general configuration wherein you provide the timeout, the amount of memory, and the corresponding amount of CPU would be selected automatically. Ephemeral storage, which is for storing data in files if your application has to do it. Then we have triggers. We have added S3 as the trigger. This is the bucket and this is the bucket ARN, and these are the event types, object created and object removed, and this is the prefix, meaning this is the folder. Then we have permissions, which are permissions needed for AWS Lambda to interact with other services, like in our case it is S3. Destinations is not needed at all. Function URL is for applications. Then you have environment variables using which you can send data to your code. We'll do that when I write the code. Then you have tags, VPC. RDS is for applications again, and concurrency and recursion detection. So concurrency is something, what is the maximum number of parallel execution that your code can have using the Lambda function that we are creating here. By default, it is 1000. If it is more than 1000, you can raise a support ticket and change it, or you can edit it here. You can reserve concurrency and provide some concurrency level here. Of course, you'll have to make some payments. So this is how we create Lambda function. Now, as you have seen, this is a wrapper for infrastructure and code both. We have not written or uploaded any code. We'll do it shortly. And after doing that, we'll have to we can test the code also. Then we have monitoring. So these are all CloudWatch metrics. How many times the function was invoked, what was the duration of execution, what is the error count, throttling count, etc. Then we have aliases, meaning that you can create alias for a particular version and you can upload multiple versions also. Right now, we'll not worry about aliases and versions. We'll just write a very basic code which will read from an S3 file and do some limited processing and write it to an output file also. But all these things are wrapped using our Lambda function. In our case, the name of the function is this one.